Hello, everyone. Welcome to homework this week. Sorry for getting this out to you so late. I was sick this week. Also, Ed Sheeran's album came out, so there was that. Anyway, you're going to be drawing on Google Maps this week, and what you're going to be drawing is a square the same size as it would take if you built a solar array large enough to power your entire state. So, to figure this out, we need to look at the number we generated several weeks ago. If you remember correctly, my number was about 25 gigawatts for Ohio. And we're going to do this on a per day basis. So the first thing you need to do is you need to take that number you generated and multiply it by 24. Then once you get that number, so Ohio would need about 600 gigawatt hours of energy per day. So then once we figure out what we need per day, then we can start to figure out how large of a solar array it would take to power Ohio or your state or whatever you're looking at. The next thing we need to look at is solar panel efficiency. This is a chart generated by NREL, and it has kind of some of the best solar panel efficiencies to date. The ones we're interested in are crystalline silicon cells. These are the most economical and really the only things that are being built right now, the only panels that are being built. They are displaying some pretty incredible efficiencies here of all the way up to 27% efficient, and their lowest is 20.8. In reality, the ones that are being built are probably more around like 15% efficient. And because I wanted to be conservative for this calculation, I used an efficiency of 15% all the way through. You can use an efficiency of 15%, or maybe if you find another number that you want to use, maybe 16, 17%, but I use 15%. Then you need to look at, okay, what are the solar resources in your state? In Ohio, I should explain, to access this map, go to nrel.gov/GIS/solar.html, and then click on photovoltaics. The data from in the poster size, this is going to be the largest, highest resolution picture. So we're mostly green here, and if you look down here, the green averages out to be around 4 kilowatt hours per square meter per day. 4 kilowatt hours per square meter per day. In this area of the country, 4 kilowatt hours per square meter per day. But if we factor in the 15% efficiency, this is the total amount of sunshine hitting this part of the country per day. But so if we factor in the 15% efficiency per square meter, we can generate around 0.6 kilowatt hours per day in the real world. This is like your standard solar panel and what it could actually be generating. If we do a little math, we can figure out that 1.66 square meters will generate 1.66 square meters will generate 1 kilowatt hour of energy per day. So then, if we look, there are 1 million square meters in a square kilometer. So 1 million times a kilowatt is a gigawatt. So 1.66 square kilometers would be able to generate about a gigawatt hour of energy per day. If we go back all the way to the start, remember we need to generate 600 gigawatts of energy per day. So if we do 1.66 kilometers times 600 for the 600 gigawatts, that gives us an area of 996 square kilometers. So if we come into Google Maps now, this is just standard Google Maps, and this is kind of your deliverable homework. You're going to measure a distance. So you just want to draw a square. And then if you come down here, you can read that this area is about 8,000, almost 9,000 square kilometers. And what we can then do, our number is 996 square kilometers. So I'm going to make this square smaller until that number way down there at the bottom gets to about, we're almost there, almost there. Almost there. Okay, that's about right there. So if I wanted to power all of Ohio with solar panels, it would take a solar array this big. And this is one of the things that's really hopeful to me about solar, is because, as you can see, our solar resources are absolutely enormous. And the next thing that I want you to do for homework is look up some of the other land uses in your state. So for instance, agriculture is a big use of land in my state. It takes up 13.6 million acres. I converted acres to square kilometers, and it gives me 55,000 square kilometers. So if we come back to Google Maps, and if I make a square, I did this earlier, so I kind of know how big it is. But if I make a square that is around 55,000 square kilometers, you can see the agricultural land, or the amount of land in Ohio we devote towards agriculture, absolutely dwarfs the amount of land that we would need for solar panels. The other thing, and then you can also go in and look up just a couple other areas, developed land, forested land, see how the amount of solar would compare to other large users of land in your state. All right? Just take a screenshot of these boxes that you draw, and then turn them into me. All right, awesome. See you guys next week.